All right, we're going to get to the last lecture before I looped around to what we were doing last spring. So this is the last lecture before all the classes were canceled last spring. And then so you might see some lectures afterwards being somewhat, they hopefully will be exactly the same as they were, but I might reuse some of the old lectures from last spring, depending on what the quality is. So let's go over pointers. This is brand new concept, but it's not really. In fact, we've been seeing pointers for a little while now. But let's just review what we've been talking about. When we make a new variable type, a data type like an integer or a float, we allocate space in memory somewhere. Where? Don't know. Don't care, actually. I give it a name so that I know where I can identify where this thing is located. And when I access that value, I get the value back. I don't get the location. When I say, give me what the value is for val1, I get the number that's being stored there, or the character that's stored there, whatever the variable is. I don't get the address, but there is an address for every single one of our variables. However, we could get the address, and that's what one of the weird things about C is. Other languages have gotten rid of this, but C, one of the powerful things it has is the ability to get that address. And you'd say, why the hell would I need to know what the address of variable 1 is? Well, it allows you to do interesting things. So instead of trying to transport, my house, I just give you the address to my house and you can come and visit me yourself. That's the metaphor I like to use, but maybe you have another metaphor. I don't want the actual, I don't need to pass off the actual value. I could pass off where it is located and then I can go and get it. So here would be how I would do it. The ampersand, and we may have seen this before, but the ampersand gets me the address of the variable. So ampersand myval, like we have here, is what is the address, the location of the variable myval. Not the value, the address of it. So it is the reference of myval, where it is located. So in this case, I would output 2 for myval, and myval would be some address, and it would be different every single time I run my program. So it could be something like 0x012d, whatever. It's just some location in memory. That's what's important about this, because if I have that, now I can pass it around. So here's another example. I have a variable a. This is a very bad address. It's way too short, but I have a variable a. The name of the variable is a. The value, hopefully there you go, the value being stored is the character y, but the address where it's stored is 732. So when I say character a, I mean get me the value in position 732, but yeah, because we don't want to remember this 732, we just use a. So what is the value at position for a? But if we use that ampersand, what we get is the following. So here is what we had before. I'll put that in there again. Here we go. I have a character. I can get a pointer to a character, and I can actually store it. I can have a new variable type called a pointer. A pointer just points to things. It stores the address where something else is located. It is pointing. So character P is pointing to whatever A is. So character P also requires a position to store values because it's storing information. It is a variable, but it is storing what is in position A, where position A is located. It is storing 732, the location, not the value, the location. If I had character P without the star, if it wasn't a pointer and I just pointed it to A, I'd copy the values over. This one is saying, give me the address where A is, and I'm going to store that. Okay, why would I want that? Well, first of all, we can do all sorts of really weird tricks about it. But the big giveaway, by the way, when you're looking at this, is when you see an asterisk, that's a dead giveaway that you're dealing with a pointer for the variable type. So int star, that is a pointer. Int, not a pointer, just a variable. Int star star is a pointer to a pointer. I'm allowed to have pointers to pointers, even. It is just locate this would so a pointer to the pointer here of P would be something that's storing 738. It's a pointer to a pointer. You're allowed to have pointers to pointers and pointers to pointers. You ad nauseum, you can keep on going with this. The star tells you that it's a pointer, and we are pointing to some variable. Now, it doesn't necessarily mean when I point to this variable over here, it doesn't mean that if I say it's an integer over there, it may not actually be an integer. I'm pointing to something. What is in this cup over here? It could be if it's a coffee cup, I say, what is in this cup? You're going to assume it's coffee, but it could be anything. It could be water. You don't know. So just because you're pointing to it and saying it is a coffee cup over there does not mean that it is full of coffee. If I'm pointing to some variable over there, an integer over there, it may not be an integer itself, actually, but you think it is. I'm just pointing and saying, over there is an integer, I'm pointing to that integer. Or over there is a character, I'm pointing to that character. So a char pointer is, I'm pointing to a character over there, and most of the time it's actually a character over there. But I can point to doubles, I can point to integers, I can point to whatever. And I can do pointers to pointers to structures, all sorts of different things. All it's doing is storing a memory address. That's all it is. So pointers to pointers, I'm storing the memory address, which stores a memory address, which then stores an actual value. So here is the integer, and here's a pointer to that integer, and a pointer to the pointer to that integer. Here's another example, just a different illustration. So I have boxes, which I'm going to be putting at this position right here. This is the integer boxes are going to be stored here. The integer cartons, I think, is going to be stored in the next line, and the integer pointer place is going to be stored in the third line here. So boxes is equal to value 2. Cartons, I copy the value that's in boxes over to the variable cartons. It's another variable. I'm just going to copy the value over to the next one. That's what we've been doing before. Place, however, is saying copy over the address of boxes over to into this bucket here. So now I'm putting the address of boxes into the place variable. This wouldn't be all that useful, except for we can dereference afterwards, and we'll look at this in a second. But notice it's pointing to the location of the other one. So we have a pointer, we have a pointee. The pointee, I never use the term pointee, but the thing I am pointing at is the pointee. The pointer is the thing that is pointing. Okay. So the pointer has a memory address, is just a memory address. That's all it is. It sounds fancy. It sounds like it's pointing to something, but it's really just an address where something is in space. So PI1 is a pointer to a float. PI2 is a pointer to a float. PI3 is pointer to a float. Oh wait, they're all the exact same despite the fact that the spaces are different, because you should actually have a convention that you normally do. I think I normally do this one up top here, but stylistically they all are equivalent, but sort of choose a style. I never ever do this one. I might do this one sometimes, and I might do this one some other times, just because I want to say this is a floating pointer versus this seems to be two different things. So it depends on how you want to look at it. And we use ampersand to get the address. So here's pointer 1, and it's pointing to whatever stored in I. Since I didn't make the example, that's why the star is there.